This is section 6.2, part 2, and in section 6.1 we talked about some characteristics of parallelograms and what makes, if you have a parallelogram, what characteristics do you have. And we've got one more characteristic to talk about and discuss, and that includes the very bottom of page 2 here, where it says if a quadrilateral is a parallelogram, then its diagonals bisect each other. So, in other words, the diagonals, the opposite angles, the line that connects the opposite angles, cut each other in half. So BD and AC bisect each other. In other words, AE and CE are congruent, and DE and BE are congruent to each other. Okay? So the diagonals end up bisecting each other as well. Remember, the diagonals are connected with a line that connects the opposite angles to each other. Okay, so let's take a look here at an example. It says solve a system of linear equations to find the values of x and y in parallelogram KLMN. What are KM and LN? Now, there's quite a bit here. A couple of things that we're going to do. Okay, the first thing we're going to do is we're going to set up our equations. We know that LN and KM bisect each other. So we know two things. We know that y plus 10 is going to equal 2x minus 8. We also know that x is going to equal y plus 2. Now, some of you may say, well, wait a second, Mr. Klein, I can't solve that because I have two variables. Okay, well, this is going to take you back to Algebra 1 a little bit in solving a system of linear equations. And in this case, we're going to use what we call the substitution method, where I'm going to take, it says here that x is equal to y plus 2. So I'm going to replace the x with a y plus 2 because that's what it says it's equal to. So I'm going to take this y plus 2 and we're going to replace it. This is the substitution method. So now I'm going to end up with y plus 10 equals 2 times, instead of x, I'm going to put a y plus 2 in there and then get a minus 8. So now I only have one variable and I can solve. So I get y plus 10 equals, if I distribute 2y plus 4 minus 8, and then if I combine my like terms, we end up with 2y minus 4. Now you can just solve it like a normal equation. If I subtract y from each side, I get 10 equals y minus 4. And then if I add 4, y is going to equal 14. Okay? Well, now that I know a value of one of the variables, I can substitute this back in for the y. So now I have x equals 14 plus 2. And then x is going to equal now 16. Okay, so now I have a value for x and y. And what I need to do is I need to plug it in to find my values. Remember, I need to figure out the length of Ln and the length of Km. Well, if I plug in x to be 16, this side right here is 16. Okay, which means this is 2 times 16, which is 32, minus 8, because what I'm doing here is I'm plugging it in, plugging 16 in for x. 2 times 16 is 32, minus 8 is 24. So that length is 24. And if y is 14, this is also 24. 14 plus 10, and this is also 16. So in this case I have ln is 16 plus 16, which is going to be a 32. And Km is 24 plus 24, which is going to then equal 48. Okay, so this case, you're going to have to be able to remember this a little bit, where we're solving a system of equations. In this case, we use substitution, where we had a single variable set to each other. Okay, all right. The last theorem involves parallel lines, and it says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. In other words, as you see here, if all 3 of these lines are parallel to each other, then these transversals end up being AC is congruent to CE, and therefore BD is going to also be congruent to DF. Okay? So let's take a look here at an example. It says AB, BC, and CD are all 2, so I'm going to write those in there. These guys are all a length of 2. Okay? It says EF is 2.25. What is the length of EH? Well, what it says in this is that if all of these lengths are the same on these 3 parallel lines, then all these 3 lengths are also going to be the same. AB and EF are not the same to each other, but the lengths that these parallel lines cut into are going to be equal to each other. So essentially, this right here is 2.25, and this right here is 2.25. Well, in order to find EH, you're going to take 2.25 plus the 2.25 plus the 2.25, and that's going to equal EH, which happens to be 6.75. Okay? All right, so this concludes section 6.2, part 2. Don't forget to complete your WSQ.